Given a 1 million element array where each element is a random character in A to Z, identify the starting index of every sequence of characters that spells Waldo. Twist. Include sequences where 4 of the 5 characters match. For example, wafdo and zaldo, but not wadlo. Okay, here's the solution that I came up with. And let's go ahead and break it down. So the key to this solution is this Windows array. So let's go ahead and take a look at this guy. So Windows represents 5 character sequences from the chars array. So for example, the first row in Windows is ARPBX, which is the first sequence of 5 characters in this array. The second row in Windows, RPBXF, is the next sequence of 5 characters. And notice that it's only 1 character offset from the first sequence of 5 characters. So the way we build this array is we use the asStrided function, where we tell it we want to build a view from the chars array. We want the shape of the output to be the length or the number of characters in chars minus 4, because that's how many sequences of 5 characters we can get, by 5 columns, because we want to look at sequences of 5 characters. And then the strides parameter here, well, wherever you are in the Windows array, we basically tell NumPy that to get to the next row, it needs to look across this many bytes of data, where chars.strides square brackets 0 is just the number of bytes in any given element. So if we're at element P, to get to the next row, we're basically telling NumPy to only move across one element, or to sequence or iterate across one element. So that's why rows go just offset one element from each other in the chars array. And then of course we do the same thing for columns, because they're just offset one character from each other as usual. So the next thing we do is we build an array called Waldo with the characters in the word Waldo. And then we want to compare these characters to these characters. So we want to compare Waldo to Windows. So we say Windows equals Waldo, and we get back a big Boolean array like this, where, for example, the first false value here means that W is not equal to A. And we're interested in rows of this Boolean array where at least 4 of these values are true. So those are going to be cases where at least 4 letters in Waldo match the letters in the Windows array. So we'll say Windows equals Waldo dot sum across axis equals 1, so across the columns, and we want to pick out indices where those sums are greater than or equal to 4. Now this is going to return a tuple, and since this array here is just one-dimensional, we're only interested in the first result in that tuple, so we'll say square brackets 0. And this is going to give us the indices of what we want, the cases where at least 4 of these characters match a sequence in the Windows array, which are just sequences of 5 characters. Now, if you want to check this, you can run a little block of code like this. So we'll say for index and start indexes, okay, so we'll assign this to the value start indexes. So for index and start indexes, we'll just print empty quotes dot join cars between start index and index plus 5. And you can see that these do indeed pretty closely match Waldo, like Waldo, Wallio, Walfo. And if anybody's expecting a child on the way, maybe this is a neat little set of potential names for your future kid. Especially if you're a celebrity, I think these would go over really well.